Welcome to the Siemens Sinumerik webinar series. Today we're going to take a look at shop floor programming. We're calling it Shop Floor Programming 101 for ShopMill for milling. Today I will be your presenter, Chris Pollock. I'm the Virtual Technical Applications Center Manager and a resource here for you guys to reach out to if you have any questions or require any assistance with operation and programming-based topics. My contact information is here in front of you. Feel free to reach out if you have any questions regarding the Sinumerik product line. So today we're going to take a look at content specific to both the 828 and the 840 controls. So anything we talk about here can apply to both control platforms equally. The intention of today's webinar is to give you a really solid understanding of our ShopMill interface, which can certainly be used for shop floor programming scenarios. We're going to take a look at making holes using some standard cycles. We're going to do some pocketing, some profile milling. We're going to get a chance to see thread milling and even slotting cycles. And then we'll even add some additional functionality like incorporating optional stops or program stop commands to an existing part program. We're going to kind of break down a couple different topic areas. We're going to first take a look at the ShopMill interface as an overview. And as we're doing that, we're going to collectively build a live programming example together. So we're going to go through common operations. We're going to leverage some of the cycles that we just talked about in a real live example. And then once we're all said and done, we're going to start to take a look at some additional functionality, adding to the part program to just kind of streamline different features or functions. So before we begin, first thing I'd like to always point out is where I can go for additional reference material. And certainly when we get into the ShopMill or ShopTurn programming environments, we have some very handy manuals that have been developed and are available to you for download. This is a completely public website. You can go in and you can search a whole host of different content that Siemens has available for you. It is a very large site, so I certainly recommend if you're going to go in and you know specifically a topic you're looking for, you want to search for it. So in this case, we want to look at the Sinutrain Easy Milling with ShopMill manual. You get to that, and it's got some real great part programming examples, how to start applying it, and really kind of supports and backs up a lot of the material we're talking about today. So, as I said, we're going to be doing a live example while we are going through the interface and talking about the functionality. So here is our basic operations list of what we're going to be doing. So we're going to certainly do some face milling as our first op, just datuming the top of our part. We're going to go back. We're going to square up our feature. We use some profiling around the outside. Once we've profiled it, we're going to come in and do some pocketing features. So you're going to get a chance to see us machine a circular pocket with that 3-inch counterbore and then a through hole all the way through. That's basically a 1 inch, a little less, because we're going to thread mill a 1-inch 8th thread through the center of this part. We'll also do some drilling and tapping features. Get a chance to see a bunch of different operations there. We're going to be both drilling and tapping on the peripheral 4 holes, and we're going to be through drilling and then coming in and machining some slots. And then when we're all said and done, we want to go back and show you how to do some deburring operations by using the built-in transfer functionality into the control. So what we're going to do here is I'm going to use a piece of software called Sinutrain, and Sinutrain allows me to basically mimic or emulate a machine tool control right here on my PC. So everything I do in this Sinutrain virtual world would be the same process steps you would take when you get out onto the machine. Now the first step is to know where you need to go to start writing part programs, specifically ShopMill programs. So you are always going to want to find the Program Manager button. That can be seen either as a hard key on your front panel, or if you use the menu select key, you can also access it through a soft key on the horizontal keypad. We're going to get to show you both as we switch over to Sinutrain. From there, you're going to get into the Program Manager field or area, and that's really kind of like, for lack of a better term, kind of like Windows Explorer for Siemens or for Sinumerik. So this is where you're going to save your part programs, or we'll create new part programs. This is where you can manage external memory, whether you want to access a network drive or any additional peripheral memory you may have on the control. Once we get in, we're going to select a new part program once we decide what folder we want to place it in. And then from there, we're going to start creating a part program in ShopMill. Now, ShopMill and ShopTurn is our conversational programming environment. It is an option and would require the option to be already set up on your machine. Now, if you don't happen to have it on your machine tool, don't worry. You can add it if you'd like, and the option number is there on the bottom of the screen. Generally, it's a pretty simple piece of software to add into the system. It's really just a matter of activating it, and it should be up and running. Okay, from there, we're going to move on to the next step, which will be starting to write our part program. The first thing you're going to see when we start a new program is what we call our program header. And the header just really sets up a lot of the modal commands that will be active through the length of the part program. So we're going to go in detail, and we're going to build it specific to our job, but you're going to do things like obviously tell it the unit of measure. Am I an inch or am I a metric? What work cord am I using? You're going to set up some peripheral or perimeter dimensions for our blank, and that's going to work with our simulation or our graphics. And then we're going to tell it a little bit about our tool orientation and some retract strategies. Once you've done that, once you've accepted the program header, then you're going to drop into what we call our program editor. And this is how it's going to look like right at the control. So what you're going to see is you're going to see the header, the program header, and that's always going to be the first line of the part program. And then from there, as we add events or insert events, and an event would be an operation, like a pocket mill or a drill or something along those lines, you're going to see events start getting placed basically between the program header and the end of program event until you have your entire operations built. Now we have a series of what we call soft keys, and we have horizontal and vertical soft keys. So those are those perimeter buttons that you see, the edit, the drill, the milling, the contour mill, or on the vertical side, build group, find, mark, cut, copy, paste. So those are what we call soft keys. They're called soft keys because they're software driven. And that's how you're going to navigate through all the functionality that can be found within the program editor for ShopMill. Now, we try not to have you have to get too far in or too many layers deep. So you're going to find usually it's only 1 or 2 clicks to get into where you need your appropriate operation. So from there, the first soft key we're going to talk about a little bit is the edit function. And edit allows us to kind of do that. We're going to modify or change some of the state of the part program potentially. So this is where you'll find your cut, copy, and paste commands. We have additional commands like build group, which we're going to look at later. From there, you can use the lowest most vertical soft key, and that's that vertical soft key that has the 5 lines and then the arrow command. And that key allows you to expand the vertical soft keys if there's more options there than we're able to show. If we have more functions than we're able to have keys for, we use that lower button, and then that's going to change the vertical soft keys. So like you're seeing on the right side of the screen, that's what that vertical bar would flip to. So from there, you get functions like view or graphic view that allow you to see a wireframe of the part that you think you're creating. You can add sequence numbers. We're going to look at that a little later. Or you can even open further programs. So if you had written a program that's very similar to the part program that you're making and you want to move maybe events back and forth, you can copy and paste between programs. That can all be done in this section. So for us, what we need to do is we need to start writing our program. We need to give it a name, just like we said. We need to get into this header, and then we're going to fill out the header. So we're going to fill out the header based on specific information to our job. So with that being said, why don't we switch over to Sinutrain and take a look at what it would take to start writing this program. So here I have Sinutrain sitting in our jog environment. This would be the area that you'd be familiar with if you're going to set up or just move around the machine. Now I mentioned earlier, first thing I have to do is get to the Program Manager screen. So if I look at my hard keys, I will see in my 9 hard keys I have just above my blue arrow keys, there is a Program Manager button. Program Manager is going to automatically paste me into the Program Manager area. If you don't have a Program Manager hard key, or you can't find it for any reason, you're going to look for the Menu Select button. Now, Menu Select will give us soft equivalent keys of these hard keys, and there I'm going to see on the horizontal soft key the button called Program Manager. That's the same as the hard key. Now, if you're looking at your machine, there's a lot of new touchscreen-driven machines these days, and maybe you don't see the Menu Select key either. Well, if you have the M button up top, that performs as the Menu Select key. So I can also touch the appropriate portion of the screen where it shows my M, and the M would also act as a Menu Select button. So depending on the configuration, we do have a lot of different front panel variants. You can do one of those 3 things. But if you happen to have it, certainly the simplest thing is to press the hard key for Program Manager, and that's going to bring us in the programming environment. Now, once you're here, first you're going to see that you're in what we call NC memory. That's the internal memory, and you can navigate up and down through our tree. So in NC, we have 3 primary folders that I see right here on my display. I have the part program folder, and in there I would have part programs with an extension .mpf, stands for main program file. I can create subprograms, or I can go to a workpiece directory and I can create subfolders and have all kinds of different file extensions in those subfolders. Your part program really could be in any of these folders. Typically, it's common to place them up in the part program directory. If you have additional memory areas, you could potentially have what we call local drive. That's expanded memory on the machine. You could be creating programs on a USB stick, or you may have a button here along the horizontal soft keys that would be a network drive. So again, pick the appropriate folder you want to create programs in. As long as the highlight is just somewhere within the folder, either on the name or somewhere in it, then if I select my new vertical soft key, I'll be creating a program inside that folder. Now, just like we saw on the slide, I'm going to choose the ShopMill option, as long as I have the option or the license option on my machine tool, and then I'm going to give it a name. So in this case, I'm going to call my program Sample 1. Now, when it comes to naming a program, you can use letters, you can use underscores, and you can use numerical values. Can't use any other characters outside of that. So if you wanted to do a / or a decimal point, it's going to tell you invalid character. Now, you don't have to give it the extension. System's going to automatically assign it. So just remember, letters, numbers, and underscores. From there, select the OK, and it's going to launch the part program. Now, this is where we're seeing that header page that I showed you and I mentioned. So we can come in and we can start to fill out our header page. Now, what does our program look like? Well, I did show you a quick representation of it before, but I just wanted to bring up what the print looks like. So in our case, we're going to be machining a block. It's going to finish at a width of 5 inches and a height of 4 inches. It's going to finish 1 inch thick. So I'm going to be machining this from probably something a little larger. I do want to go around and machine the perimeter and make sure it's to size and to tolerance and square. And then I'm going to be doing some internal features. Now, first question I see on my screen is going to be what my unit of measure is. So that would most likely be, what has my part program been dimensioned as? So this is an inch part. It's an inch print, so I'm going to keep the machine in inch mode. On any of these fields, if I need to change them, what I'm going to do is I'm going to use the select key. That's this little blue key in the middle of all my arrows with the little like horseshoe look. And by hitting select, I can toggle between my 2 options. Now, if you forget and you move your cursor around and you're hovering over a field, if you see in the little pop-up, that little horseshoe come up, that's again reminding you that by pressing the select key, you can toggle or change the field. In addition, if I hit any key on my keyboard, any one I want, it'll also give me a pop-up and I can pull down. So we set up our unit of measure. Now I'm going to set up what work coordinate I was going to use for this job. Next, I need to tell the system what I want to use as far as the part shape. Now this is only a primitive that's going to be used for simulation purposes. It's not going to change the actual resulting toolpath. So here we support cylinders with holes in them as a pipe, basic blocks with the center being 0, 0, a block with two opposing corners being my datum. I support multi-sided stock, and then if I don't want any graphics, I could leave it at a value of none. So in our case, we're using a basic block, because if I look at my print, I'll see that my part 0 is in the upper left-hand corner of my part. So I don't want to establish the center in this case. I'm going to use, maybe that's my back fixed jaw. So we'll use that as the part. Now, let's say for argument's sake, looking at the part, we're going to say that the rough stock I'm machining this from is maybe 1/4 inch oversized, so 5 1/4 by 4 1/4. So potentially, I'm going to want to accommodate for that to kind of center my part within my stock. So when we come over and we touch off that edge, whether I use a part probe or an edge finder, I'm going to leave a little material on the left side and the top side when I touch off. So that's the same thing I'm going to do here. When I'm setting up the model, I'm just telling it two opposing corners. Either one, in my case, I'm using the upper left-hand corner and the lower right, or I could use the lower left, upper right. It doesn't matter, or go backwards. So I'm telling it that I'm going to have an 1/8 inch of stock on one side, because remember, we're going to finish at 5 inch. So I mean, my stock would be overall a 5 1/4. So I want to take half of that material, or an 1/8. So I'm going to tell it that my X datum, or reference, my starting point is going to be a -125, and the Y is going to be a +125. Then my overall opposing corner, which in this case I'm describing the lower right-hand corner of my stock, is going to be 5 1/4, or 5 1/8, shall I say, excuse me, -4 1/8. Now, you see how I have the absolute symbol to the right of these commands? Whenever I see that, that means that I can change that dimension from an absolute or an incremental value. And I'm going to do it the same way. I'm going to use the select key to toggle between those two fields. So if you don't see anything written to the side of it, that's immediately telling you that that field or that input field is an absolute value. You can't change it. Or it could be an unsigned value depending on the operation. But again, it's not editable. It's not changeable. It's a fixed value. Top of my stock, once I've described my two opposing corners, it knows the length and the width. It needs to know thickness. Now, in this case, I did say I was going to take a facing cut. So I'm going to leave a little material for a facing cut. I'm leaving 30 thou. And then I'm giving it some overall thickness. Now, I'm saying I'm grabbing by 1/4 inch from the bottom of the part. That's going to be taken off a little later. I can set that to an absolute or an incremental value. I'm going to make it an absolute value. Maybe I'll make it a little less. Maybe we're only holding it by a 125. So we got 1 1/8 inches. Okay. Then you have your default tool plane. So this is going to control what the can cycle knows the z-axis orientations to be. So I can set it to G17, 18, or 19. So let's say you had a right angle head. You could tell it you're in a G18 orientation. And now your drilling cycles would actually drill in that orientation. Or I'm going to stay in my standard G17 plane for a vertical machine. Retract, where do I go when I'm done with the physical cycle or even my end of program? Once I'm done in any operation, where do I retract to? And then your safety distance is how close do you wrap it to a surface before you start feeding. So right now we're wrapping to 100 thou of any given surface. This is an unsigned value or an incremental value. Now you do have your machining state, and that's really, do I want to climb mill or conventional mill? So down cut is going to refer to climb milling, up cut is going to refer to conventional milling. And if you watch our little animated element, you can see if you forget which is which. As long as you know the difference between climb mill and conventional mill, you can see it right on the screen. Final question. We're drilling. We have multiple planes. Do I want to send the machine always up to my retract plane every time? Now it'll rapid back and forth, but it will move way up to, in this case, 1 inch above the part. Or do I want to let the system optimize and only retract when is necessary? So you'll know that based on the type of program you're creating. If you have a lot of clamps in the way, you might want to veer to the safe side and always retract to the retract plane. Now, once an event like this has been filled out properly, you're now going to hit the accept key, and that's going to save the event into the program, and now show us the editor like we were seeing from the graphics before. From there, we're going to use these peripheral buttons, the horizontal soft keys, and then the vertical soft keys to build our program. So currently, we only have one event created, which is our header. Now you see how there's a little arrow command here? That's just telling you that if you hit the blue arrow to the right, you can reopen the event, make any changes you want, hit accept if you want to save it, cancel if you want to just jump back out and continue programming. So that's what that little arrow means. That's how you edit any event. So as you create more, we can always go back in and edit them. Okay. So once we've certainly started the program, now you're going to decide, well, what am I going to do? What kind of tooling or what kind of operations am I going to need to do to start to make this part? So in our case, we're going to do some milling first. So I figured we'd kind of jump over drilling for a moment, and we'll segue into the milling section. So in milling, you have a whole series of canned cycles. We're going to be specifically looking at the face mill, the pocket, and the spigot command. In our case, we're also going to get a chance to use the slot and the thread mill. But just to give you kind of an overview, one of the only cycles we're not going to get into in this webinar is the engraving cycle specifically. But you'll find that the cycles are very intuitive. So once you've gone through a couple of them, you can pretty much figure out what we're asking in any of these variables. So in our case, we want to go in and we want to create a facing toolpath. So we're going to use the milling horizontal soft key, and then I'll see the vertical soft key is going to pop up, and it's going to give me the face milling button. By selecting that button, we'll then go in to our input screen, and we're going to fill out the page from top to bottom and just kind of answer each question as they come. When we're all said and done, we save it, we're going to see that face milling event will have been inserted just below my program header, hence starting to give me some operations in my part program. So moving back over to Sinutrain, we're in the program editor. We're going to select the milling horizontal soft key. Then we're going to go up to the upper face mill vertical soft key, and that's going to allow us to access this cycle. Now, once we've entered into a physical cycle, we're going to kind of want to just fill out the cycle from top to bottom, kind of like it's just each option is just a question. So the first thing I see at the very top of the screen is what tool do you want to use for this operation? So at this point, you want to select a tool from the tool library. Now, you may not have a tool already created, so we are going to go build one, and we'll show you how that whole process works. So when you're on the tool field and you see it's in orange, you want to use the select tool key in the upper right-hand corner. That's going to give you a quick little reference of your existing tool changer. Now, if you don't have any tools created, what you're going to do is you're going to hit the tool list button again now in the upper right corner. So same button, just change the labeling a little bit. And that's going to drill us all the way back, or drive us all the way back to our offset table. So now you're just going to go down to an appropriate spot where you want to create a tool, and we're going to use the new tool button to actually build that tool. So by selecting new tool, you can now access an entire tool library that we have available, from creating end mills, face mill, which we're going to do right now, all sorts of different drills. If you don't see the tool you're looking for, then take a look in some of the other areas. So cutters, drills, special tools, there's all kinds of tools available. Normally, in most cases, you'll find what you're looking for in the favorites field. So in our case, we're going to come down to the face mill or facing tool to create a face mill. Select OK. The machine's going to build that tool type. Now, it may give you a suggested name. It all depends on if the parameter is turned on or not, or just give you a blank. In my case, I'm going to leave the facing tool recommended name. I'm going to call mine a 3-inch facing tool. From there, you're going to hit the input button. It moves your cursor over. I'm going to give it just a default length, just to have something from a simulation perspective. You're going to touch these tools off later. So I'm going to give it just a negative 15-inch. Certainly, you could be using positive or negative tool length offsets. Either one is up to you. Then you're going to give it the diameter. So this would be saying that my cutting path is going to be a 3-inch diameter. When I come over to the end field, that's number of flutes, or number of teeth on the tool. So let's say this is a 5 insert shell mill. My direction is important. That would be the direction of spindle rotation, and whether I want coolant to be turned on or off for this physical tool. You'll notice inside of ShopMill, you don't drive the coolant commands or the spindle direction. It all gets driven from this tool. Additionally, if more information is required, you may see a further data button pop up. And this just fills out the rest of the information about a tool. So if I happen to have a face mill that's got a 45-degree angle to the tool, so the actual body is bigger than 3-inch, we can tell the system that here. And now if we send this tool up to a wall, it's going to know how big its true diameter is and then stay within the wall accordingly. Once you've filled out the additional information, just hit the back key, and now you can hit to program. And what the system is going to do is it's going to take the tool name that you created and insert it right into the tool field. From there, we're going to move on. We're going to give it some speeds and some feeds. So, from our feed rate perspective, just like we saw before, I can select basically whether I want to be in feed per minute, in this case inches per minute, or I can use the select key with the horseshoe and toggle it to feed per tooth. So the system can actually calculate feed rate for you based on the parameters of feed per tooth, and then when you get to RPM, you can do RPM, or you can set constant surface feed. So if I look at my insert pack and for a given recommended material, maybe it says that I want to run at a surface footage of 3.5 thou per tooth, or shall I say a feed per tooth of 3.5 thou, and a surface footage of, let's say, 1800 for that tool and that material. Now if I come back and I select or toggle back to the feed rate, the system will even show me the calculated feeds and speeds for those cutter scenarios or cutter parameters, excuse me. So with that being said, you can leave it in either field. It's really kind of up to you if you want to leave it at feed per tooth or feed per minute, and same thing with constant surface speed or RPM. Next option, next field is machining or machining state. So what do we want to do? So a single diamond refers to a roughing operation. That would mean that I'd have multiple cuts in Z. Triple diamond would refer to a finished operation. Now, in this scenario, I just want to take off 30 thou, so I'm going to leave it at a finish op. I can control my cutter direction with this little symbol right here, so I can change it from a bidirectional toolpath to a unidirectional toolpath, or I can do a bidirectional in Y or unidirectional in Y. Then it's a matter of just filling out some basic parameters. So whenever I see the X, Y, or Z 0 field, this is what we call our datum for the cycle. So basically, I need to give it some parameters that the cycle is working within. Now, these values were automatically filled out for you based on the header page. This is the only cycle that actually pulls data from the header page. So that's where it came up with the negative 1/8 by positive 1/8, the positive 30 thou, because I gave that in the header page, and the overall length and width. Now what it didn't do, and you just want to make sure you have the right value in here, is where do I want to end? That's where my X, Y, and Z1 represent, right? X, Y, Z, that's kind of a starting position, and this is the ending position to describe the shape that I'm cutting. So in my case, I want to end at a value of Z0. Now, I can control my radial engagement or my step over. Again, using the horseshoe, I can toggle between a linear distance or a percentage of the cutter. Myself, I like to use a percentage of the cutter. This way, if I change my tool, my radial engagement will change to whatever the new tool size is. Now, whenever you see a U, that's referring to a finish amount. So any value I leave here is going to be kept away if I'm in a roughing scenario, or in a finish would be used just to calculate what the material would be left for a lead in, let's say. So in this case, we're going to just tell it we're at 0. We're just bringing everything right to plane. We accept or save, and we see the event gets inserted. So once we've faced off the part, then we have some profile milling to do, right? Next logical step in any part would be to datum the top of the part and then kind of square it up. So what we're going to do is we're going to come in here. We're going to use 2 cycles because in this case I want it to rough and finish the outside of the part. Let's say for argument's sake my geometric tolerance, my dimensions are pretty tight, or just surface quality is an issue. So whenever I leave material from a roughing cycle, I do have to remember to take it off with another event with using the triple diamond to represent a finished pass. Once we've added those, we're then going to get a chance to use our simulator function. So the simulation is going to bring up a 3D model and actually allow me to see a tool moving around in space. Now, when looking at the vertical soft keys that get launched, once you hit the simulation button, upper right-hand corner is going to be cycle start and reset. Below that, I can change my view orientation. So top view would be me looking down as if I'm looking at in the G17 orientation plane. The 3D function is an option, so if you don't have it, it can always be added to the control, but this allows me to get full 3D simulation, and if I happen to be on a 4 or 5 axis machine tool, we can actually simulate 5 axes in this mode. Or I can use my further views and look at the system from the left or the right side of my orientation. So from there, we're going to transition over to Sinutrain and continue writing the program. Now, if we bring up the print, let me pop that up here real quick. I'm going to need to machine around the perimeter and then finish that up. So I'm going to use, we'll create a tool, maybe a 3/4 inch tool to come in. Remember, I have an 1/8 of an inch of material around the part, and I also want to put in this nice corner radius, which is a 250 radius. So we are in the editor. Our highlight is sitting on the face mill, so it's going to insert below. I want to make sure I'm in the milling function. If I'm not, I'm going to hit the milling button. And then I want to choose my spigot. And again, spigot, the multi-head spigot is referring to frame milling or boss milling, most commonly referred to. Now, when we come into the cycle, if you see the option for complete or simple, that's just going to reduce the number of variables on the screen. So sometimes when you're first learning it, it's nice to maybe switch it to a simple and just concentrate on what the immediate stuff I have to fill out is. We're going to leave it all complete for these examples. Now, when you go into the cycles, I want to pick the vertical soft key that represents the shape I'm machining. So is it a rectangular, circular, or multi-sided spigot or boss? So for our case, it's a rectangular. Now I'm going to come down and start filling out the operations. Now in this case, the last time the cycle was used, it was left at a chamfering up. So I can jump down and I can change that to a roughing operation if I want. And now I'm just going to see that it looks more like a traditional roughing scenario. First question is going to be, what tool am I using for machining this out? So I'm going to go to the select tool. I'm going to go back to my tool list because we need to create a new tool. So now in pocket 3, I'm just going to build a new tool. It's going to be an end mill. And I'm going to call this my cutter 3/4 of an inch. So that's my 3/4 of an inch end mill. Again, give it a basic length. I'll keep the same lengths for this example for now. When we get to really run it the part, you'll have to obviously set these. It's going to give the system my tool diameter. Now, you want to pay attention to the symbol on the top of the page. If this doesn't have a diameter symbol, this could be radial. So it's really a machine parameter. It's up to the builder whether he wants to set them up to be a radius value or a diametric value. This one's set up for diameter. How many flutes? I'm going to do 3. Whether I want my coolant, my direction. And you see I get no further data. It means I'm done. There's no other information I need to worry about at this point. We select the To Program button. Fills out the new name. Now the D1, that gets filled out automatically for me. In this case, I'm only creating one offset for the tool. We do have the ability in advanced scenarios to create multiple offsets for a tool, and that's where the D number would come into. That would correlate to the physical D column in the offset table. So if you create multiple offsets, you'll see a D2, D3, D4, all the way up to potentially D9. But when you're just building your first tool, that's always going to be at a D1. Okay. Feed rate, again, just like we showed, feet per tooth, feet per minute, same thing with RPM, toggle between them. Now the reference point we didn't have to do in the facing side, what we do here, and this really has to do with the datum location. Where do I want that to be relative to? Do I want it to be relative to some corner, because that's where my dimensions came from, or do I want to be relative to the middle of the feature? Now this isn't the part, but this is the feature, in this case the spigot. Now in our scenario, it happens to be one and the same because we're machining around the perimeter of the part. So I'm going to leave it at center, and then when I come down to do my X0, Y0, that's going to be working off the middle of the part. I do need to tell it if I'm roughing, finishing, or you'll notice in this operation we even have the chamfer option, which we'll do later. We're going to rough. If you see single position or pattern, that just means that if I had to do multiples of this operation, so let's say it was a pocket and I needed to do 10 in a row, I could link this to locations just like I do a drilling cycle, and then it would machine 10 pockets in a row for me. In our case, if I'm just doing one, I want to leave it at single position. We tell it where the center datum feature is of the part because of where our reference point was left. So mine's 2.5 inch over, 2 inch down, according to my print. Top of the part's 0. My rough stock, so remember 4.25 by 5.25. Now this is just going to control my lead in and lead out move onto the part. My finished dimensions, a 4 inch by 5 inch block. My corner radius, which is on my print, is 250, so we would type in a value of 250 here. If my part feature was tipped at an angle or not, mine is not, so I'm going to leave it at 0. The overall depth of my part, so I know it's going to go to at least 1 inch. My depth per pass. So maybe I want to take this in 2 passes, so I'm going to give it a value of 0.5. And then, as we said before, in a roughing operation, if I have a U value, this is the material it's going to leave on for me to come back and take a finishing operation on. So I'm going to, in this case, leave 10 thou on the X and Y walls of my part, but I'm not going to worry about coming back and finishing the Z bottom because at some point I know this is going to get faced off. So we fill out the page, we hit accept. That inserts it now below the facing cycle. Now in our case, we got to jump back in and we got to give it a finish pass. So if I just come straight back to the multi-edge spigot, you'll notice the system retains all the information that I just plugged in. So I don't have to type it all over again. It's going to always leave the values that were just last entered into the field. So in my case, maybe I want to slow down my feed rate or kick up my spindle because it's a finish pass. I do want to tell the system I am doing a finish pass. And then I want to come down and I want to tell it maybe I don't want to do multiple finish passes. Now you could come right down the surface. I could do 2 or 3 or 4 finish passes in the Z, or if you set the depth of cut, which is what our DZ represents, to equal to at least the total depth or more, you could go larger. It'll just go right down to the bottom. It'll never exceed the Z1 field. Now, before we had a value here that was telling us to how much material to leave on the part. Now we want to leave this value because this is what's going to control our lead in. If we set it to 0, you may not have enough material for the system to calculate what the lead in is. So I'm going to leave my 10 thou, and if you start to increase that number, you can see it would just change the ramp in move on this this feature. So we fill out the page, we hit accept. Now we get our rough and our finish. So at this point, we can now simulate, and we can take a look at our simulation package. So if I hit the simulation button, system's going to come in. It's going to start our simulation while we're just on a top view. So I'm going to see my cutter come around the top. There I can see my multiple depths of cut and my final finish pass. Since we have it, we look at it in a 3D. We can use the cycle start button to restart it, and now we can see it machine the feature in 3D. And as I mentioned, you could also use further views and look at it from a front view, back view, right view, and then I can back up and maybe go back to my 3D view. So here we can start to see it's starting to look like our part program. Okay. So once I've squared up my part, next logical operation based on my part print is going to be my pocketing cycle. So in the pocket, we got a couple things we're going to do. First thing I'm going to do is I'm going to pocket out that through hole, basically that 1-inch through hole. It's a little less, 900 thou, because we are going to thread mill the part. And then I'm going to come back in and we're going to do the 3-inch counter bore. So we're going to rough out the pocket, the center pocket. We're going to then rough out the 3-inch counter bore, and then we're going to do a finish pass on that 3-inch counter bore. So at the end result, we're going to get 3 separate events to handle coring out the center of the material. So as we transition over to Sinutrain, we can start to add in those events. Now let me bring up the print so you can kind of keep an eye on it. So first we're going to, again, machine this center pocket. So if I look at the pocket print, this physical hole is going to be a 1-inch 8 thread. So if I wanted to go in, we could certainly check in the machinist handbook. Here it's giving me an 875 through, so that would be what I would want to machine that bore through. So we want to go to milling, and if you come into the last event, that's okay, just hit cancel. We don't need another rectangle pocket, because in our case we want to go to a circular pocket instead of a rectangular spigot like we were just in. So select the pocket vertical soft key, and then again, remember I got to pick which one I want to do. So it defaults to a rectangular pocket initially, but here I can go into a circular pocket as well just by clicking the vertical soft key, and now we're going to fill out the page. So if I want to use the same tool I just used, which in our case was the 3-corners end mill, I certainly can for all this. I don't have to keep picking the 3-corners tool. If it's there, you can leave it, but it's a modal command. So again, you don't have to keep picking that tool. I'm going to leave it blank. We're going to give it some feeds and speeds. Same rule applies as before. I'm going to choose my operation. In this case, I want a rough. Now, in circular, I got 2 different machining strategies. I get helical, which will do a helix all the way to the bottom, kind of like a thread routine, or I can do it called plane by plane. So we're going to show you both. First one I'm going to do is a helix. Especially when I get to deep hole pocketing, I get much better chip evacuation when I'm using a helix. In this case, too, I don't have a lot of peripheral material to take out. Really, the material I'm machining is more deep than it is wide. So this works as a great strategy for that. Single position or pattern, just like I showed you before, we're going to use a single position. What is the center of my pocket? Our part's 2.5 over, 2.5 down, or 2-inch down. What is the top of the pocket? In this case, it's starting at 0, Z0, top of my part. The diameter is 0.875 according to my print. The through hole is how far I want to go, and this can be an absolute or an incremental value. Remember, whenever I have this field, that means I can use my select key to toggle it. In our case, I want to go probably just to get through the part. So if I know the part is 1 1/8 inches, maybe I'll go 1/30. And remember, it's 1 1/8 inches because that's what I told it was for the rough stock on the header page. What do I want my radial engagement to be? So she's going to helix down, and then if it didn't have enough based on the diameter of the tool and the tool path, she's going to then step over 25% of the cutter and helix again until it achieves this outside diameter. The p-value, that would be my lead-in pitch. So you'll have to know how aggressive with the tool you're using the ramp-in can be. I'm using 1/8 of an inch per revolution. Might be a little aggressive in some tools, so you certainly want to use the recommended feed-in angle of that given tool. But the center cutting tool, you can get pretty aggressive with it. Do I want to leave material for a finish cut? So we're going to bring everything right to size. So I'm going to say no. So in this case, I'm just going to hit accept, and that's going to put in my circular pocket. Now I want to come in and I want to do my counter bore. So I'm just going to go right back to pocket. I'm in my circular pocket still. It retained all my values. Now I'm just going to change what I need to change. So we're still roughing, but I do want to do a centric or a plane by plane machining strategy now. So here it's going to come down to my first depth of pass, machine all the way out to the 3-inch minus whatever material I leave for a finish cut, and then move down again my next step and continue on. Single position stays the same. Center of my pocket stays the same. Top of my pocket is Z0, that's good. but my diameter is actually going to be 3" per my print. So we're machining to a 3" counter bore. The depth is shown in my sectional view is going to be in 1/2" deep, so I'm going to give it -0.5. My step over, maybe we're going to do 50% of the cutter diameter. My depth per pass. So let's say we want to take it in 2 passes. I'm going to say 125 for my depth per pass. Do I want to leave material for a finish cut? Sure. So we can leave 10 thou on the wall, and if I wanted to make sure it's a nice clean bottom, maybe I'll leave 10 thou on the bottom as well. Now, this helical isn't going to machine it all out. This is just the ramp in. So you get a couple ramp in strategies in this case. I can do a helix or a plunge vertical. Plunge vertical would actually work fine in this scenario because I already know there's a hole in it. But if there wasn't a hole, you would certainly want to use a helical ramp in. You do need to tell it how aggressive your lead or your revolution is going to be. This is going to be your lead in depth. So per rev, how far you advance. And then what's the radius that you're revolving about. Now we have another option called removing. You can use complete machining or remachining. And what that does is that allows us to accommodate if there's a portion of this pocket feature that's previously been machined, whether it was drilled or however it was machined. So in this case, I don't need to waste time trying to machine the center of it. So I can now tell it that, okay, a total of a 1/2" material by 0.875 has been removed. Now, I know the feature is actually longer than that, but the cycle is not going to want you to give it a depth any greater than the physical cycle. So if I tell it 1", you see that it's going to give me an alarm. So just go to the total depth if you know that your feature that's been removed is equal to or greater than that depth. It is an unsigned value. You notice I'm not giving it a negative. In fact, if you give it a negative, it's going to give you an error message or an alarm. And this is our error message checking. So typically, if you get through the cycle and can hit accept, you're pretty good. So we're going to accept it. Now we're going to just jump right back in to our circular pocket one last time. I'm going to take a finishing cut. And now, in this case, I want to finish everywhere, the floor and the wall. So I'm just going to pick finish. I can use the same ramp-in strategy, or if I wanted to, we could go to maybe a plunge. I'm going to just drop down at 20 inches a minute until I'm at depth, and then we're going to clean the bottom and the wall of the feature. I'm leaving my previous values. This way she knows how much material is left on the bottom and the side. Save the event, and now we can do a simulation and start to see that we're moving right along here. So there's our counter bore, and here you can see our finished cut. So it finished around the wall, then finished the bottom and the rest of the wall. We'll go back to the editor, and now let's see what our next operation is going to be. Okay, so once we've cleared it out, now we can start to drill some holes. So under the drilling cycle, you're going to see there's a bunch of events there for me, or cycles there for me under drilling. So we're going to get a chance to use centering, drilling, and deep hole drilling. But there are boring as well. A boring cycle would be for a single point boring head. And this way, if you have a indexable or orientatable spindle, we can actually orient the boring bar, pull off the wall, pull out of the hole without dragging that bar up along it. It also gives you obviously a much more optimized machining strategy for that type of boring head, as opposed to just using like a drill reaming type of operation. And then we're going to use the threading to do some tapping, as well as the position commands to tell it where we're going to drill. So in our job, we got a couple different scenarios. I got to center drill some holes. So here you're going to get a chance to see not only how I set up a can cycle, but how I link the positions as to where it's going to drill. And in our case, we're going to get to drill on a couple different planes. So we're going to drill around the top and then drill down on our 1/2" pocket. So you're going to see how we get to handle that type of feature. So inside a Sinutrain, let's bring the print back up. So you keep an eye. We're going to have 4 holes around the outside that we're going to spot drill, and then we're going to spot drill this bolt hole pattern that's down a 1/2 inch deep. So I want to go to the drilling field. Again, my highlight's going to stay on my last op, so it's always going to insert below, and we're going to pick the center drilling option. So in center drilling, I'm going to pick a tool. I don't happen to have a tool created, so I'm going to select New. I do have a center drill option, so I'm going to pick it. And I'm going to say that this center drill is my 3/8 of an inch center drill. We're going to give it a default length like we did before. Now, I don't necessarily need to define, obviously, the cutter diameter of a drill, but I need it for simulation purposes. So it's not going to change the tool path at all if I don't have it, but I'm not going to see it actually drill. So I do want to give it, and then I want to give it an accurate tip angle. So in this case, I'm saying this center drill is a 90 degree. Now, this isn't a combination center drill. This is a true NC style spot drill. If I need my coolant, certainly remember the appropriate spindle rotation. Say to program, plugs in the name, fill out speeds and feeds. Now, when you get to drilling, it's not feed per tooth, but it's feed per rev, like you would typically know right out of your tooling catalog. And it's still surface footage or straight RPM. So either scenario you can use. Now, when we get to the depth option, how do I want to compensate for the depth? I can compensate based on the true tip. Now I have to tell it how deep I need to drill. But what's nice about the center drilling routine is I can also tell it what the size of my countersink is going to be. And the system will calculate the depth. So that's why it was so important for me to put the appropriate angle. So I type in a spot diameter of 300 thou. If I looked at the print, it would tell me it wants a countersink of 90 degrees, 300 thou. So that's what I was looking to get. Perfect. And then do I want to dwell at the bottom? So sometimes if I'm breaking through, it's nice to give a little dwell there. Hit accept, and now you're going to see something a little different. Here, we see this little open-ended bracket. That just means we need a little bit more information. So I know how to drill, I don't know where to drill. So that's where you're going to use the position buttons to describe where we're going to drill. So when you go into positions, we got a bunch of different scenarios here. We have random holes, which we're going to use for our 4 outside holes. But I can do arrays. That would be just a linear row of holes. I can do grids. I can do a grid of holes or a frame of holes, and the frame would actually work fine for this scenario as well. And then we can go into bolt hole patterns, complete bolt hole or partial. We're going to use the bolt hole pattern next. So first, let's go to random. Now with random, you're going to get 9 potential hole locations. It starts at the location of 0 and goes up through 8. If you need more, you can then save as many of these events as you need. In our case, I don't want to have any of the numbers that were here, so I can use the delete all button to get rid of them. I do want to tell it the plane at which I'm drilling from. So if you noticed before, it knows the spot drill size, but it really doesn't know where it's starting from. And you're going to tell that right here in the cycle. So that's saying that this set of holes is sitting at Z0, top of part. Now you're going to give it your coordinates. So if I look at the print, my first hole is a 1/2 inch over, and mine is a 1/2 inch down. Next hole, if I'm going to go straight over to my right, it's going to be 4.5 inches over. I'm not moving in my Y, so I can leave it blank. Now I'm coming straight down in the Y to minus 3.5. That's going to put me at the lower right-hand corner hole. Now I'm going to move back. Since I'm all absolute, I'm just going to move back to an absolute position of 0.5. And I'm not moving the Y, so I'm going to leave that alone. So now I have 4 locations. 0 is my first location, 1 is my second, 2 is my third, 3 is my fourth location. Once I've filled them in, I can always look at graphic view, and then I get a nice little wireframe of my part so far of my operations, and I can see my locations. So had I maybe had a typo, I can see where it would put the hole off the part. So it just gives you a quick representation of where those holes are going to be. I hit accept. You see it inserts the event. Now I want to come and do the bolt hole pattern. Now this is a little different because my bolt hole pattern is down inside this pocket by 1/2 inch. So that's where the Z0 comes in handy. I can use the same can cycle as long as my depth is going to be the same on that cycle. And then I can just use a couple different location strategies for where the top of the part is. So in this case, I'm going to put minus 0.5, then define the center of the bolt hole pattern. Angle of my first hole, so a value of 0 would be 3 o'clock. A value of 90 would go up to 12 o'clock, and it goes counterclockwise from there, right? So a value of 180 puts me over at 9 o'clock. The radius of my bolt hole pattern came right off my print, inch and an eighth. Number of holes, and then how do I want to position between the holes? Do I want to just go shortest path, or do I want to follow the radius of the part in case there was a boss or something in the way? Hit accept. Holes are in. If we simulate, we should now see it do some spot drilling for us. So we face off. Now the simulation is always going to start from the beginning. There are ways to speed up simulation or slow it down. We'll see that in a second. But you can't easily start from the middle. So there is our 4 spotted holes, and there are our spotted holes. And if you saw it, it stayed down. It didn't keep jumping all the way back to the retract point until it was said and done. Okay. So if we go back to our operations, we now see it's time to drill some of these holes, right? So we're going to have to do some deep hole drilling. So we are going to use the deep hole drilling cycle because we're going to peck drill. We're going to say that maybe we don't have through coolant on this. I want to pull out of the hole, or I just want to break the chip, let's say. So we use the deep hole drilling to fully drill the 4 outside perimeter holes. We're going to use our tapping cycle. And what's interesting is the way we structure things to kind of reduce the number of events it would take to create a part. If you're doing multiple operations on the same series of holes, you can set up the can cycles first. So in this case, I'm going to do the drilling and then the tapping, and then tell it the locations, and it'll do all operations on those locations. Now, for our case, I need to redo the positions that were done during the center drilling op, so I'm going to use the repeat positions function to go back and reuse those. Now, I could just do those positions all over again, but now I'm managing the same geometry in different locations, and I don't want to do that. So where the highlight is, I want to go to drilling, and I want to cancel out and back up because I need to get to the deep hole drilling operation. Now we're going to fill out the deep hole drilling. So we're going to build a tool. So I'm going to cheat and use the name I had used previously, but in the tool library I don't actually have it yet. So we're going to create it. So we'll build a new drill. We're going to do a twist drill. And we're going to call it, what's nice is you can cut, copy, and paste in all these areas. So I'm going to call it a number 7 drill. I know it's a 15-inch length. It's a 201 drill. And I want to know the geometry. So I'm going to assume I'm using a 118-degree tip. To program, make sure it's filled out. Now, just because the name is here, if it doesn't exist in the tool library, you do have to build it again. So the ShopMill interface isn't going to necessarily delete the last given name that was in here if you deleted the tool. That's just a reference for you. You can still do feed per rev or feed per minute. We're going to do feed per minute. Same thing with RPM or constant surface speed. We have a couple different chip removal operations, so chip breaking or chip removal. We also have a deep hole drilling routine that would allow me to accommodate a true deep hole drilling where I need to pilot it and then insert a long deep hole drill slowly into the part before I start up the spindle. That's all accommodates this deep hole drilling 2 cycle. So the standard deep hole 1 is our traditional deep hole drilling or peck drilling or chip breaking routine. So we're going to do a chip breaking. Actually, let's do a chip removal, so we'll pull out of the hole each time. How do I want to compensate for the tip, for the depth of the drill? So if I do shank, the Z1 value is actually going to be at the edge of the tip. And then this way, the system will actually drill deeper than Z1 by whatever it calculates the tip rejection to be. That's why it's so important for you to give me the right geometry of the tip, the drill. If I set it to tip, now it's only going to go down with the tip to whatever I have in Z1 field. So that's how I can control it. So if I know I want to do a breakthrough, we have a depth of 1 1/8". I can use shank, and I should get right through the hole. My first feed, that's FD1. So do I want to go slower than the 10 inches a minute for that first in feed? And then how far in do I want the first in feed to be? And then from there, the percentage of every previous or following peck. So if I put a percentage number in here, it'll reduce the D value as it pecks deeper, deeper, deeper. So if I'm getting a lot of chip packing, I might want to make that peck smaller and not be as aggressive as I was when the flutes were certainly out of the hole. How much do I want to back up? And then do I want to do a dwell at the bottom? Fill out the page, you hit accept. Now we did mention we were going to tap some holes, so I can tell it that now. I do have to build a tap. So I'm going to go in to my tool list, create a new tool, and this is going to be a tap. So pick the tap right out of the library. Give it some name for your reference. I'm going to call mine a 1/4-20 tap. We'll just give it a default tool length for now, tool diameter, and the pitch, if you're an inch, is going to be the threads per inch, so it's going to be 20. And so no matter how I program the physical pitch in the tapping cycle, if the machine's sitting an inch, then in the tool table, the tap has to be built as threads per inch. If the machine's sitting in metric, this becomes the true metric pitch. So like a M6/1, I would put a value of 1 here in the table. Okay, we can define the geometry by some pre-built tables, or I can leave the table off, and now under the pitch field, I can use my select key, and I can toggle between a bunch of different thread geometry types. So I can do threads per inch, I can do a modulo thread, I can program a metric pitch, even though I'm in an inch program. I can give it an inch pitch. Now, if you're doing threads per inch and you don't need the fraction, just remember to cancel it out. So if there's a number here, I'll just do 0/100, and this is 20 threads per inch. If I was doing 20.5, I can put 21/2, and that would give me 20.5 threads. My RPM, right, she's going to calculate the feed. That's a constant based on the 50th thou pitch of my thread, but my RPM is up to me. So in this case, I'm going to come in at 500 RPM and retract at the same RPM, but I could use a different RPM if I wanted to. I choose whether I'm rigid tapping or soft tapping by with or without compensating chuck. So with a compensating chuck would be a floating tap holder, and that would be soft tapping. Without a compensating chuck is rigid tapping. And then from there, I can do one cut or I can peck tap. So you're only going to be able to peck tap if you're in rigid tapping. If you're not in rigid tapping, you notice you don't even get the option, because obviously in a soft tapping scenario, I can't go back into the hole. So we're just going to go one cut, how deep I want to tap. I'm going to accept it. And now I want to call up the 4 outside positions. So again, I could copy and paste that down here, but now I'm managing the same locations to 2 different spots. Or I can use the position repeat field. I just want to pay attention to the number that was associated when these positions were built. It did that automatically for me. So I just do position repeat, tell it the value. So I'm going to tell it number 1. It's going to show you the 4 holes, and they're going to be highlighted here. Might be a little hard for you guys to see, but it's just indicating to you that that's what position 1 is going to do. I accept it, and now as we simulate, we're going to see our 4 holes. Now I'm going to speed up a little bit. I can use the Control-M command to speed up. So now you see we're drilling those holes, and then I tap, tap, tap. There's our outside perimeter holes. All right. So moving on, we're now going to finish our holes. So we're going to come in. Now, in the lower holes, I don't have as much material to go through, so I'm just going to use the drill reaming function. And that's going to be a scenario where it's going to feed to depth and then pull out of the hole. So the drill option feeds the depth, rapids out of the hole. The reaming portion feeds the depth and feeds back out of the hole. And then we're going to call up the other set of positions to finish it up. So under drill, I want to get to the drill reaming option, and then we'll fill out this page. So I got to go build a 1/4 inch drill. So let's go create a 1/4 inch drill. Again, new tool. I'm just making them all in consecutive order. Certainly, if this tools were already created in your library, you have to make sure that they're in the appropriate pocket. All right. Give it some name. We'll give it a default length, the diameter, tip geometry. Send it to the program, define our feeds and speeds. I have the same option like before, tip or shank. So if I want to make sure I'm breaking through, I can tell it. Now here, I could give it an incremental value or an absolute. So if I looked at my print, I know I am at a 1/2 inch plane now when I drill these. So if I want to use a value like incremental, it's the distance from there to the bottom. So that'd be a 1/2 inch plus another 1/8. So 625 plus the shank should just break me through. If I was maybe doing some kind of a pre-spot drilling operation, I could do that. I've already centered, so I don't need to. Or if I'm accommodating for a tapped hole, I could give it a little overrun. You fill out the page, save it. Now we're going to go back to our position repeat. We're going to grab positions number 2. It gives me the bolt hole pattern. We do a final simulation, and we should have all of our drilling done. So we're just about done. We just got a couple more operations to go. Going to speed it up here. So now we see our 4 drilled holes. If I rotate it up, I can see, and you can rotate with your mouse, dragging it around, push down your center wheel, and you can rotate around. But there we see we're just breaking through, straight through our part. Again, because we're using that selection, not tip, but to the tool edge, so the compensated geometry. So once everything's drilled, now we got to do some slot milling. So we're going to jump back to the milling cycle, and we're going to choose our slotting option. And slots got 3 different primary strategies. I can do open slots. I can do what we call encapsulated slots. That's where it'd be like a captured key. Or I can do these circumferential slots where they're wrapped around a radius. So we're going to do circumferential slots in this part. From there, maybe we'll take a look at some different types of options we have in simulation. So I can start to speed up or slow down. I mean, you saw me use Control M, but you can actually adjust the overrides directly. We can also turn on a show path if I want to see what the tool path looks like. Maybe I want to get a little better example of what the physical movement of the cutter is going to look like. So back in our part program, just make sure your highlight is right here at the bottom, just above end of program. We're going to go to milling. We're going to escape back because we don't want to do any rectangular pocket commands. Because what we want to do is we're going to go to the slot command. Select slot, and here you see your 3 options for slots. So longitudinal slot would be an encapsulated slot, like a captured key. Circumferential is what we're going to do here in a second, and that's going to be wrapped around a radius. Or I can do an open slot, and then open slot would be more like a tricoidal tool path where I can come through and clear out that slot geometry. So for circumferential slots, we're going to wrap them around a radius. Let's bring up our print. So that's going to give me these 2. So even if you just had 1, you could still use the same cycle. You're just going to tell it down here when we get there to the number of slots you have. In our case, it's 2. I do need to go get an appropriate tool. So if I look at my print, I got a 3/8 slot width. I see that right here in the sectional view. So I got to make sure I use a tool that's going to fit within that geometry. So go select tool, go to our tool list, and let's create a new tool for that physical slot. So we're going to select new tool, end mill, and this is going to be probably going to use like a 5/16 tool in that scenario. That should be adequate enough to get into the slot, just a little smaller than the 3/8. Now in these fields, maybe you don't remember right off the top of your head what the diameter equivalent of a 5/16 tool is. You can do basic math, so I can put a fraction in, let's say, and it'll calculate it for me. Again, number of flutes, especially if I want to program feed per tooth, that's a must. If I'm programming inches per minute with straight RPM, then it's not going to need that, the number of teeth. I'm certainly going to want to give it the diameter, because for our cutter compensation, it's going to need to know it. So the tool's in again, give it some feed rates. Same scenario applies. Feed per tooth, feed per minute, same thing with RPM. I'm going to tell it what my operation is. So we're going to rough it out. Now when I come to roughing, you notice it popped up an additional field, and that's how fast do I want the Z to come plunging in. Excuse me. So I'm going to come down 10 inches a minute and then machine out the peripheral, depending on my material. So she's going to feed into a corner. I happen to already have drilled holes there, so I can feed in no problem. Am I doing a full or a partial? So depending on, depending on how the geometry lands, I can do a full pitch or a partial. If you were just doing one, it really wouldn't matter which one you chose. What's the center of the feature? So what are they revolving around? So in this case, 2.5 over 2 down. Where does the top of the slot start from? Ours is down in a 1/2 inch pocket, so I'm going to leave a 1/2 inch. How many am I doing? I'm doing 2, so I have a value of 2 there. What's the radius? So per the print, it's the same radius as the bolt hole pattern, so 1 1/8. The starting angle of the first slot and the ending angle of the first slot. So if we bring up our graphical view, you can start to see if I plug in numbers here, it starts to move my slots around. All right. So we just want to get it where I want to start my first slot, and if I set this to a 1, I'll only get 1 slot. So maybe I want to start my first slot at 3 o'clock. So I start a value of 0. I know based on my print, my included angle of my first slot is 90 degrees. So there I have 1 slot. And then if I do 2, since I'm doing full circle, they're going to be indexed perfectly apart. So now I get the 2. If I was using the pitch, then I would have to tell it where the next one's starting and ending. So depending on your material, or depending on your print, shall I say. Okay. Slot width, 3/8, as we mentioned before. Slot depth, so absolute or incremental, but if it's incremental, it's based on the Z0 datum. But in my case, I'm using an absolute. Per the print, it's 3/4 inch down. Depth per pass, we're going to take it all in one cut. Certainly, I would probably be a little bit more conservative if I was really machining this part. Do I want to leave material for a finish cut? I'm just going to bring it right to size. And how do I want to position between the slots, just like before with the bolt hole pattern? I can follow the radius or not. I fill it out. I'd accept. There's no brackets. I don't need any more information. So I should be able to simulate this tool path. From here, if I want to see that show path of the wireframe, you're going to use, again, this lower expanding key to change the vertical soft keys. Right, so I'm going to click on that until I see the Show Path button. That's going to show me all of the tool path. Now, if it gets a little muddy, you can still leave it on but use Delete Path, and that'll only show you the tool path from wherever you're at moving forward. So you can kind of clean it up if you still want to be able to see it, but maybe I really only want to be able to see what's going on inside of those slots. So there's my drill. So there's the slots. Now I see my tool path in there. I can also go into program control and adjust the speed at which it's moving. So the percentage of override is not linked to your machine panel overrides, because you can be concurrently programming or simulating while the machine's running. So it's actually this field right here. So when I go into the program control vertical soft key, I can move my overrides up or down, and then that's going to change the speed at which it simulates. So if I want to slow it down, you can see it starts to go a lot slower. I can go to 100%, which I'm at, or you can override it all the way up to 120%, and it's going to go super fast. That's the same as me doing the Control M like I was doing before. If you don't want the path on anymore, you can just toggle it off. And I'm going to put my speed back to 100%, and that quickly places the override back to 100%. Okay. So we're just about there. We got to come in and thread mill, and then we're going to do a little deburring. So the thread mill cycle, that's going to allow me to come in and machine this thread mill feature. Now when we get into thread milling, that's going to be found under milling, but we do have to give it our positions, so we're going to use the position screen, and that's going to be under drilling. Because you notice nowhere on this thread milling event does it ask you the X and Y location of it. This way, if I had 30 thread milled holes to do, I could just link this as if I was tapping them, and I wouldn't have to do different operations in each one. Now, one of the things I'm showing you here, I always like to make reference to it, is we will calculate the true cutter feed based off of a linear feed rate. So when you're given linear feed rate in a referred to you by a tooling catalog for thread mills, that's a straight linear feed. But what happens is, obviously, if I'm OD or ID, they don't know the diameter of your thread mill tool, the diameter of part, so they're not going to give you the true calculated feed rate. So our control will actually calculate that for you. So if I program 20 inches a minute, I'm going to see that actually move either quicker or slower when I run it in auto, and it's using this standard formula. So if you're ever curious what the thread mill formula is for calculating the actual feed at the cutter edge, because what I need to know, this would be the formula used, and that's literally right out of a thread mill manufacturer catalog. Later on, I'll have the last slide. I have it up there again too, if you want to jot it down or just email me. I'd be happy to provide it to you. So let's go add a thread mill. So we segue back to our part, and now we're going to come in. And we're going to edit. We're going to insert under milling. We're not the slots, but we're going to go to the thread mill, and we're going to fill out our thread mill cycle. I do need to give it a tool, so let's just build our threading tool. Last one. Now here you see the thread mill isn't visible. I have to go to the cutter option, and then I see the thread cutter. Give it whatever name. I'm just going to leave it default. Some depth. Whatever I know my diameter to be on my thread mill, how many flutes I have on that thread mill through the program. And now we're going to fill it out the feeds and speeds. So here I can use the select key and do feed per tooth or feed per minute. Remember, this would be a linear feed. Then the system is going to calculate based on the cutter diameter and whether I'm OD or ID, if it has to increase or decrease that feed rate. RPM or constant surface feed. Am I roughing or am I finishing? We're just going to rough this out. Do I want to work from the top down or the bottom up when I'm machining? Is it a right hand or a left hand thread? Mine's a right hand. Is it an ID or OD thread? Mine's an internal or an ID. Now in this case, this is the number of actual teeth or threads that one revolution of the thread mill will make. So you do need to tell it how many you have, and you want to be accurate about this. Because if you tell it more, it's going to try to do that entire geometry, maybe only 1 or 2 revolutions. So, it's going to calculate based on the thread geometry I'm going to give down here, how much per your depth, right, per the depth of the thread, how much that thread tool would accommodate. Now I give it my depth of my thread tool. Maybe we'll let it thread all the way out. So let's say, for argument's sake, I knew mine had 6 teeth. Okay. What's the geometry? Just like the tap before. What is my ending diameter? So remember, we machined an 875. My ending diameter would be 1 inch. I can give it my thread height. So I know I'm ending at 1, and my hole is 875. So we can do a little math here. I can bring up a calculator if I hit my equals key. So I can say 1 minus 0.875, and that would be a 125. And then the thread height would be half of that, right? So I could do divided by 2. I come up with my 625 is going to be my thread height, and then I hit accept, and it plugs it right into the field for me. So again, I can type the math in the field, or I can hit the equals key if I want to bring up a calculator. My depth per pass, so let's say I go 20 thou radial engagement, and then it'll obviously machine out until it gets all the way to the outside. Do I want to limit it for a finish cut? Always U. And if I want to control my starting lead in, if I'm timing the thread to something. You hit accept, you can see it's just like the drill. So now I just have to come over to drilling, go to the position screen, and we're just going to give it the location of the thread. So in our case, it's going to be the center of the part, but down a ½ inch. So I want to make sure I tell it my Z location for top. And this is going to be 2.5 over and 2 inch down. I only have the one hole. I accept it. Now if I simulate it, we're going to see the thread mill come in and thread mill that feature. We'll speed it up. All right. Slot. Oh, I went too fast. Let me start it again. All right. We'll drill holes. There's your slots. And, oh, I see I am up in the air. Oh, no, I'm offset. This is a good case to maybe put our path on. Oh, I see. So it's down there. So what did I do wrong? Sounds like a typo to me. Ah, I see what I did wrong. -2. That'll do it. Accept. And everything else should be good. Yep. Absolute -1.25. One more simulate. And there we go. We see the thread mill come down. You don't get you won't actually see the teeth per se of the thread, but you will see the tool path. So we can show the path on. If I cleaned it off, you'd see just the little helix that the thread mill does. We can start it one last time to show you. Okay, so it's going down, cleaning things up a little bit. Just jumping a little further. All right, so there is my slots, and there I go. There's my little path in there. And if I want to get a little further in, I can go into details, and we can use things like zoom, let's say, and I can start to see the geometry right in there. So in this case, the number of teeth, I was able to do it all in one shot. All right. If not, I would see a couple different planes. And that, again, would be driven really based on the number of teeth I gave it. Oops, I went too far back. Number of teeth I gave it, and the overall, it calculates out to be the depth of the thread. Okay, just about done. So here, if we come back, we're going to see where we're going to do a little deburring real quick. So this is just a nice simple example of how I can start to use my cut, copy, paste command. I can go grab each of the features and now just pick a new tool to chamfer and change some very simple parameters, and I can add in deburring quite quickly. So we're going to deburr the outside perimeter with the rectangular spigot. We're going to do the 3-inch counterbore, the 1-inch counterbore, or the 875 counterbore, and we're going to do the slots as well. So I usually will start kind of from the top down. So I'm just going to grab the finish pass of the spigot cycle. I'm going to copy that, and we're going to paste that down here. And then I know I'm going to use the finish cycle of the pocket, the counterbore. Let's copy that, paste that, and I'm going to use the slotting cycle, let's say. So we'll just copy that and paste that down. Oh, and I want to edit each of these. So I'm going to go grab a tool. Now I can build a chamfer mill if I wanted to. As long as I'm not programming feet per tooth, you can actually use center drills for chamfering, or center drill definition. Works pretty well too. So I'm just going to use the center drill for my chamfering op. Give it some speeds and feeds that will obviously be appropriate for it. You got to make sure you select chamfer, and now you just have to tell it the chamfer size. That's your FS. So I'm going to do a 20 thou chamfer. and my insertion depth. So you want to make sure you insert the cutter at least equal to, but usually I like to go a little bit deeper than the chamfer size so I don't roll a burr. I'm going to make that change for each of those operations. So in this case, we're doing the 3-inch counter bore, and we're going to be doing a 20 thou chamfer, 30 thou deep. We'll do the slots. Chamfer. Now here I'm going to make sure I delete the tool, right, because I don't want to go changing to an end mill. And 20 and 30, that should be fine. Simulate, and we should now have a complete part. So I'll just do a quick auto zoom. Maybe we'll take the path off at this point. I'm going to go back to zoom, center it, and now we'll peck drilling, tapping. Let's get our other holes, machine our slots, thread mill, and now we're going to get our chamfer, a nice little corner break around our 3 features. Certainly I could go back if I wanted to put one in on that feature as well. Okay, so we have a complete program. So here we're just showing you a few more of the features that I can do inside a simulation. So I just showed you quickly the zoom. What's nice inside that area is I also can do a rotate with the buttons. So if I'm on the machine and I don't have the luxury of a mouse to articulate the rotation, I can pick the rotate view and move my rotation around with these keys. We also have a sectional view, so I can activate a cut, and I can cut out the feature or the model. Now, what we didn't show you, and we're going to be going into in a later webinar, is some of the advanced cycles. So we do have contour milling, and that's what's going to handle all of our irregular shapes, regular pockets, irregular profiles. So keep an eye out for that. That's coming in the future. Additionally, we have a lot of advanced commands found under the various field. Now, one of the most common ones would be the setting option. So what if I wanted to change one of the settings that's in my header page halfway through? Like I want to change my retract value or my safety distance. Well, that's what the setting page does for you. But here you can access high-speed machining, you can call up sub-programs, you can do all kinds of set commands, mark and repeat. The transition functions allow me to move my part 0 around either linearly or radially. So there's a lot of features found within various. We're going to also go into some of those in the contour milling webinar. Now, what's also useful when you're starting to program is sometimes things don't perfectly fit in the mold of it's a pocket, it's a circle, it's going to work within a can cycle. Sometimes the best way is just doing point-to-point toolpath. So if you expand the horizontal keys over with the gray arrow key, you can access the straight circle command. And in straight circle, you can do tool changes by themselves. You don't have to be inside of a cycle. You can just move the machine around in a straight geometry or doing circular toolpath. And then we can even get into a machine functions option. So I can set like op stops or program stops and that kind of stuff. So the op stop, the way that would work is I can insert a page. I'm going to pick either program stop, and that would represent what we're usually more used to hearing in the industry would be like an MO1 optional stop. That's what we're calling a program stop. And then the stop command is going to be more like a program stop behavior. So the program stop on, that's going to be looking for the optional stop flag or to be set. The stop command is going to work like a traditional program stop. So that means whenever I see it, I'm going to stop. So if I want to insert that into my program, it's really as simple as just kind of picking the point at which I know I want the machine to stop. So maybe I want to stop it after I do my counter bore, but before I start drilling. And maybe I want to do an inspection point. Maybe I know I'm getting a lot of chip buildup. I want to stop and clean some chips out if that's a problem. So just highlight where you want to insert below. To get to the straight circle, I got to hit the arrow over gray key. That's either going to be this soft key on your display if you have a touch screen, or you'll see a gray arrow button, usually down to the right of the display. That'll expand our horizontal keys over. Now you can go into straight circle. You see the vertical keys we were just talking about pop up, and now I can get into my machine function. So here I can give it maybe like a program stop, and this is going to force it to stop every time. And what's nice with that is it even stops in simulation, so you can even prove out. Now optional stops will not stop in simulation, but program stops will. So here you see it comes up to this point, says, hey, I got a machine stop function. I now have to press the cycle start button inside of simulation to continue on. That's the same way it would behave in the physical machine. If you chose, again, if I chose an ops stop scenario, this program stop, now it would just blow right by it in simulation. In my run mode, I got to make sure under program control that I'm choosing my M01 ops or program stop option 1. That will make it stop at those command points. Now you probably noticed when we were just expanded off, we had a couple of extra buttons. We have the measure workpiece or the measure tool field. So if you happen to have the option, I have the license option here at the bottom of the screen for what we call in-process measuring. So that would be measuring in auto mode. So the Siemens controls automatically come with the ability of doing measuring commands, part or tool, in jog. But if you want to do it in auto mode, it is an option. By getting the option, you get these cycles not only in G-code, which I've talked about in some previous webinars, but we also get it in ShopMill. And then from there, you have a whole host of cycles, as you see, to be able to measure parts, create reports, change datums. Maybe I want to reset my work coordinate because my work holding for my part automation isn't quite perfect. A bunch of different things you can do here. So you can do that both for part programming and tool probing. You can check, did I get a chip break? Did I break my tool? Do I want to just resize for wear of my cutter? All that can be done during your part program run, even in ShopMill. Now there are some additional functions I just wanted to kind of highlight here. So we've been talking about the insert function a little bit. So just to kind of reiterate, because this is an important one, just always remember that wherever the highlight is, she's inserting below that highlight. Now, another thing that's kind of unique that a lot of conversational systems don't have the ability of doing is inserting G-code in the middle of a conversational program. So the inserting G-code command will actually allow you to place any kind of G-code instruction in the middle of a part program. As well, the end of program function has a little bit of utility there. Nobody really thinks to actually open up end of program as if it's just a basic line, but you can actually turn on a repetition function. So if you have automated work loading or part loading, you can have this automatically cycle the part program. And the other one I like to use a lot is the Control-G command, and that gives you a quick graphical representation of the part. So that would be really the same if I hit Control-G right now. Oh, sorry, I got to move my highlight over it. It would show me the geometry, and then you see this little kind of design window of all of the cycles. So as I move my cursor up or down with my arrows, you see that the highlight changes to whatever event I'm on. I got to that with a Control-G, or if you go to Edit, expand over, and go to Graphic View, it does the same thing. So I can either go over to Graphic View, or if I remember the hotkey, I can just hit a quick Control-G to get into the graphics. So when you get these programs and you're looking back at them and they're starting to get a little long, it's nice to be able to get a little wireframe representation so I can kind of see the ops and then maybe realize, oh, okay, I just scroll down quickly because I want to get to the spot in which he pockets out those. So I see, oh, that looks like a slot. And oh, certainly I'm highlighting my slots. So now we can just close it. Oops, I closed the program, sorry. I want to close it with a Control-G. I close it, and then I would be at that corresponding event. So again, wherever I leave the highlight, Control-G, and I don't have to kind of search and try to figure out what each of the features are. Now, I can start adding some different things to my program once I have it roughed out. And one of the things I like to add, I find it makes it a little more readable, especially once I'm starting to run product and I want to kind of get a better idea of where in the part sequence I'm in. I can add sequence numbers. Also, if you start to get alarm messages, it's nice. It gives you the exact sequence number that it was in. It makes it a little easier than just saying pocket, and you go, oh boy, I have 4 pockets in the program. I know it's N35 pocket. So you can go in and you can start to create sequence numbers. So that's going to be done all with that edit function like we talked about. And you have 2 ways. You can do a renumbering command, so I can add them if they weren't already there, or resequence them. Or I can have settings automatically insert them. So in the program, it's really just a matter of being on the edit button, expanding our vertical keys over until I see the renumbering command. And oops, I must have still been running my part program. So I'm in a renumbering sequence. I tell it what the numbers are, so N5, N10, N20, whatever the increment's going to be. I say OK, automatically inserts the sequence numbers for me. The settings option, if I had this set to yes, then it would automatically build as I created it. I don't usually do that myself because I find I move a lot of things around when I'm first roughing in a program. So I like to add the sequence numbers after. A couple last things here to show. So one of the areas I like to use the G-code line for is adding in operator messages. So here I can actually force a message to pop up. I'll see it in simulation, but I'll also see it in the run screen by using our message command. So at any point I want to, I can just hit the input button to insert a G-code line, and then I'm going to type the command MSG, and inside parentheses and quotations, whatever I want my message to display. So in this case, op1 facemill will be displayed whenever the message command has been pushed. Now that will stay on until I precede it by another message, or I clear it, and clearing it, I would give it the message command with an open close parenthesis, and that would clear any previous messages. So just to show you, let's say for argument's sake, down here I want to add just before my drilling, I want to add a message. So highlight just above where you want to insert the G-code line, hit your yellow input key, you get the G-code line, type MSG, open close parenthesis, give yourself a set of quotes, type the message. So maybe I'm going to call it drilling ops. Once that command is there, then you'll notice as we simulate, once that comes up, it's going to stay up for the length of the program. So we're machining around. Maybe I'll crank up my override just a little bit. Make it go a little quicker. So we pocket it. And we're going to get into the drilling here once it finishes up the pocket. So you see the drilling ops on, but the drilling op's not going to go away even though we've finished drilling it. So you would have to clear that message with the message clear. But you could just have a new message go over top of it. But see, it's going to just maintain that message for the rest of the length of the program. So if I don't want it to happen once my drilling is all said and done, you can again, a lot of times I'll just copy. The beauty of cut, copy, and paste. And just get rid of the message. So now as we run it, so it's just going to finish up the pocket, fast forward it up a little bit. We get the drilling op in, and we'll finish up. You see the message goes away when I'm doing the rest of my ops. So, you don't always have to obviously be doing some kind of elaborate G-code instruction when you're using the G-code command. The message command is certainly a handy one for that. Now, there are some other features like adding groups. The groups work nice if I want to kind of consolidate a bunch of events into a smaller segment, so I'm not looking at them all the time. So under the build group option, it's really just a matter of giving it a name for the group, and then you'll end up getting this group with these, it'll give you a little plus in the name of the group. You expand it by right arrowing over, and then you can just kind of copy and paste which groups you want into that, and you can expand and contract those groups accordingly. Now, the other thing we can do, if you notice, and let me just jump back to it real fast, as I'm simulating, you end up getting a cycle time here once the simulation is complete. But you may actually want to do a little bit more cycle time analysis. So we have a couple options under settings. You can get cycle time estimates based on each line, or if you apply groups, based on each group. So here, instead of just seeing a total cycle time and just trying to figure out, well, what operations really kind of chewing up the bulk of my cycle time, especially if you're chasing some cycle time, you can turn this on just by changing the setting for determine machine times, and then it's going to give you my by block or by group, which either one. Okay, so from that, we are going to open up to some final questions. I did want to put a couple frequently asked questions up here. Certainly it's common for guys maybe to have interest in our key websites or that support site I mentioned. As well, I wanted to display that formula I talked about. So that's the thread milling feed formula for you. And we do have a couple questions that came in. So first question, I've been programming my step over with percentage. How do I change to an absolute value if I can? Okay, I did mention that briefly before, but it was kind of brief. So what our question is referring to is like something like a pocket, right? I've been defining my radial engagement as a step over. So if I want to change it to an absolute value, just remember to hit your select key, and it'll change to an inch value. But I certainly better update it because it's not going to be calculated based on what that percentage was. Okay. Does adding an option like ShopMill and 3D require a service call? So generally, I would say no. Most of our options, those including, are pretty much set up right out of the box. So it's a matter of just turning on the license. So you're going to want to refer to the machine OEM, whoever you purchase it from, to see how they like to handle doing it. But in a lot of cases, they'll just give you a simple procedure. You purchase the option. You have to put in a unique code into the machine, a couple of clicks, and the option is active. Does the feed rate override in simulation affect program run? And no, it does not. And that's the exact reason why we're using a separate feed strategy over our override knobs. So this way you can be running part programs while you're programming other stuff. And can you save the cycle time report? Oh, okay. So I was showing you the different ways to generate that cycle time real quickly here at the tail end. So if I'm doing it in my run screen or my auto screen, there are ways that you can actually have it automatically build a cycle time report for you. And that's actually turned on in the auto screen. So when I'm executing a program and I expand my horizontal key buzzer, go into settings, I can do record cycle time and save them. And now it will build a file for me if I set these two up. And the file will just be found in the Program Manager area. Okay. So that was, I think we got all the questions. So I want to thank everybody for attending today. Hopefully you got a lot out of it. If you have any questions, want to follow up, or want any of this material, please, by all means, feel free to reach out to me. I would say email, which is on the screen right now, would be the easiest way. With that being said, thank you, and I look forward to seeing everybody again in the not-so-distant future. Have a great day. Bye-bye.